If body temperature is 37.6 degrees Celsius and the temperature outside the body is 20, calculate the rate at which energy is used to warm air up to body temperature. We are given the specific heat capacity of air, 1000 joules per kilograms per Kelvin, and in the previous question we found that in each second the mass of air taken into the body is 1.25 times 10 to the minus 4 kilograms. So we have got a change in temperature of the air, and to do this there needs to be some energy input which comes from the body, and we need to find that. We are given the specific heat capacity, and that should remind us the equation that we can use to find the energy that needs to be given to make a change in the temperature of some amount of substance. And the equation is E is equal to M, the mass of the substance, C, the specific heat capacity, and delta theta, which is the change in temperature. So this equation tells us the total energy to increase the temperature by a certain amount. However, we need to calculate the rate at which energy is used, and rate means energy given or taken in per time. So we are actually interested in energy divided by time, and doing that to dividing by t on the left hand side, we need to divide this side by t as well. And I only wrote t below mass m for a particular reason, and the reason is because we don't actually know the total mass value. We are given the mass taken in each second. So we actually, the value of 1.25 times 10 to the minus 4 is actually mass divided by 1 second. So what we need to do is consider 1 second, and then the rate at which energy is used, which is E over T, we can write that as P, will be the mass over the time being 1 second, which is this number there, 1.25 times 10 to the minus 4, times the specific heat capacity, 1000 from there, times the change in temperature. The temperatures are given in degrees Celsius. Normally we would need to convert those into kelvins, but because this is a change in the temperatures, we don't actually need to do that conversion, because the difference in kelvins and difference in Celsius will be exactly the same. So in this particular case we can avoid the conversion, and we can just say 37.6 minus 20, and these numbers will give us 2.2 watts.